Tonight you'll learn about medians and altitudes of triangles. So let's look at medians first. Median is a segment whose endpoints, so if you're looking at this line, endpoints, so A and D, are a vertex, so A is that vertex, and a midpoint of the opposite side. That makes it a median. So it has to go through the vertex to the midpoint. So therefore these two sides are going to be equal. BD is equal to DC. The three medians of a triangle are concurrent and meet at the centroid of the triangle. So it's called a centroid. So P is a centroid in this case. So when you draw those medians from the vertex to the opposite side, midpoint, like that, then you get a point here, and we call that the centroid. So P is the centroid. And what that happens, it divides each of those sides into equal parts. So for an acute triangle, you have these two sides are equal, and these two sides are equal, and these two sides are equal. For the right triangle, you have these two are equal, these two, and these two. And an obtuse, same thing. These two are equal, these are equal, and these are equal, and those are your centroids. Now let's look how we can apply it. So there is a theorem for this, 5.7, congruency of medians of a triangle. The medians of a triangle intersect at a point, which is P, that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So if P is the centroid of triangle ABC here, then AP, so AP is 2/3 of that whole line there, AD. And BP, so BP, is 2/3 of BF. And CP, going from C to P, is 2/3 of CE. So you're starting at the vertex, and you're determining it that way with the 2/3. So if this is 2/3 the length, this one must be 1/3, right? So let's look at an example on how you would use that. Example on how to use medians. So I have a triangle here and the medians are drawn. So therefore you know that this is equal to this one is equal to this, and this one is equal to this one. P is the centroid of triangle QRS, and PT, so from here to here, is 5. They're asking us to find RT and RP. Well, we already know that RP is going to be 2/3 of the whole thing. So I'm going to write that down. RP equals 2/3 of RT. I also know that PT, that short part right there, is going to be equal to RT minus RP. That's what's left over. And so that gives me 1/3 right there. Remember how I said up here, if this is 2/3, this one therefore must be 1/3. So PT is going to be 1/3 of RT. So let's look at how to solve this. So I know PT equals 5. And if I know that PT equals 1/3 of RT, I can plug that 5 in for my PT and solve. And when you solve this equation, you get RT equals 15. And then what you do is you go ahead and look over, whoops, I'm sorry, this is RP. Now we're going to find RP. So I know RP is 2/3 of RT. So we found out that RT was 15 here. So what I did is I plug it into the equation. RP equals 2/3 of 15. And when you compute that, you get 10. So therefore, RP equals 10 and RT equals 5. Let's look at another application. So let's say they need you to find the centroid, and you have sides or coordinates. How do you do that? So it says find the coordinates of the centroid. So we have P as our centroid. We have J, K, and L as our vertices. So the first step is use Kn. So I have Kn, so from here to here. And find the coordinates of n. And the reason I'm finding the coordinates of n, the reason I can, is because I can use the midpoint formula between JL. So in order to find those coordinates, what I do is I plug it into the midpoint formula. So I do 3 plus 7, which are my x, and 6 plus 10, which are my y, and I divide it by 2 because it's midpoint. So the point for n is 5, 8. So know that the coordinates for point n are 5, 8. So the reason I found that is, I'm going to put 5, 8 here, is if I know this is 5, 8, then I can find the distance from k to n, find out how far apart they are. So I know that k is 5, 2, here's my k, and I know that n is 5, 8. So if I use the distance formula, which I could, but it's a straight line so I don't need to, the distance formula and counting would give me 6 units. And so I have my 6 units, and I know that Kn is 6 units, but I want to find out, well, what is the distance from, we're going to find the 2/3 value. So we want to find pk. So we know that 2/3 of 6, so 6 units, is 4 units from k. So if we go 2/3 from k, we're going up from 5, 2, and we're going 1, 2, 3, 4. Going right up there. So I know that my centroid has the units of 5 because it's straight under the n and the k. But I'm going to add those 4 units to the original k point for the y. So then that'll give me 5, 6 for my centroid, my P point. We're also learning about altitudes of triangles tonight. All the altitude is a perpendicular segment from a vertex to the opposite side. However, remember, it's got to have that right angle. So we have those right angles. It's not just a median. It's going to have a right angle. All triangles have 3 altitudes. Let's look at the concurrency of altitudes of a triangle. The lines containing the altitudes of a triangle are concurrent. That means they're going to hit. If AE, BF, and CD are the altitudes of ABC, then the lines AE, BF, and CD intersect at some point. So it's just saying that if you have these altitudes, they're going to have to intersect at some point. Okay, use all this information for when you come in tomorrow. Have a good night.